Today we're going to look at some real-world math, and that real-world math is known as exponential functions. And where might you find these exponential functions in the real world? Well, turns out these days we find it every single day in the form of coronavirus or COVID-19. What's happening, or at least what happened at the beginning of the crisis, was that the people that started to get infected, there wasn't that much of a growth in the number of people that started to get infected. But because of the experience of medical experts and epidemiologists, they knew that when you have a virus, it tends to spread at an exponential rate. And then as we began to monitor more data on the number of cases, what we saw was, sure enough, this virus was spreading at an exponential rate. And even worse than that was that the death rate for coronavirus was spreading at an exponential rate. Now, I have to tell you that for years I've been listening to people in the news talking about exponential growth, and a lot of times the word is misused. And so in today's lesson, we're going to talk about what exponential growth is and maybe a little bit about what it's not. So we'll start off with the idea that there are exponential functions, and there is exponential growth and there's exponential decay. You can get a lot of something, like you can have a lot of viruses, and they grow and grow and grow. Or you can have stuff that goes away. Like when you buy a new car and you take it off the lot, what happens is that that new car, it will, let me see if I can do this for you. It will go down. Okay, I'm having a problem with my left and right. Sorry about that. Anyways, when you buy a new car, it goes down in price. It doesn't go up in price, and it does not go down at a linear rate. When you drive your car off the lot, it decreases quite a bit in value, and over time, it decreases less and less in value. That's exponential decay. So if you ran into an exponential function on the street, what would it look like? Well, it's kind of in this form over here: y equals a times b to the power of x, and a is some initial amount, and then b is the base, and x is the exponent, and it makes more sense if we look at this function in one of these two forms over here. A lot of times when we're talking about like certainly the growth of money, or money going away, we'd see it in one of these two forms. If we're talking about buying a new car and taking it off the lot and it depreciating in value, we'd use a formula that looks like this. Whatever the rate is that the car goes down in value would go here where this little r is, and then we do 1 minus r, and that gets us our base, and then we would raise that to the power of the number of years that you hold the car for, and a would be the initial amount that you paid for the car. Y would tell us how much the car is worth after so many years. Over here is another way to write exponential function, except this is exponential growth. This would be like if you put money in the bank and the bank paid you interest. R would be the interest rate, sort of like this R is the interest. This would be the percent that you go down for your car. This would be the percent that you go up. Interest rate is a percent. So for instance, you could make 5% on your money, or 3%. Sadly, those numbers are pretty big these days. Really, more realistically, these days you're making less than 5 or 3% if you put money into a savings account. Anyways, so you add 1 plus that rate, and then you multiply it times itself by the number of years, or the number of compounding periods. We'll talk about that in another video. And then a is the initial amount that you put into your savings account. Now, it turns out these formulas can be used for other sorts of things, and in fact, they can be used to monitor and to predict the growth of a virus that's spreading. Before we go too much further, I want to go back and touch upon something that hopefully you already know, is about how things increase in a linear manner. And it turns out that two of the most useful functions that we study in algebra are linear functions and exponential functions. And sometimes we are not entirely sure what we're dealing with. So right now we're going to take a moment and contrast and compare what a linear function is versus what an exponential function is. And hopefully that'll give you a better understanding of how they differ and why exponential functions can be so scary when you're dealing with something like coronavirus. So first of all, I want you to notice this table. I have x values that are going up by a constant amount. So add 1 to -2, I get -1. Add 1 to -1, I get 0. Each of these x values is going up by 1 each time. And then the y values seem to be increasing. And what I'm hoping is maybe you can pause this video and see if you can predict what the y value is going to be for this blank and this blank next to the 3 and the 4. Pause and get back to me. Okay. I'm hopeful that you guys have figured out what goes in those two blanks, and whether you did or not, I'm going to tell you. See, the y values are going up by a constant amount. Every single time they're going up by 7. So 4 plus 7 is 11, 11 plus 18, 11 plus 7 is 18, 18 plus 7 is 25. So this guy here has to be, oops, let me see if I can fix that. That guy has to be 39, because 32 plus 7, and then 7 more will be 46. And just to make it so that these look like decent notes, let's go ahead and make sure that we know when we go to this next guy, we do plus 7. When we go to this next guy, we do plus 7. And that is kind of the magic behind linear functions, is I can call something a linear function if the y value increases by a constant amount while the x value is increasing by a constant amount. Okay, so that's a linear function, and it happens to be an increasing function. We can also have linear decreasing functions. The things go down at a linear rate as well. But right now I'd like to contrast and compare this to exponential. Okay, so here is some data. Again, the x values are all going up by a constant amount. In this case, the y values are also going up, but they're not increasing by a constant amount, at least not by adding a constant amount. So I'm hoping that you can go ahead and pause the video and see if you can figure out what goes in this box next to the 2. Go ahead and pause, take a moment, see if you can figure out the pattern and see if you can figure out that number. I don't know if I'm going to bother with 3 and 4 right now. I think there's enough points here for us to get a pattern. Okay, I'm hopeful that you paused the video and that you took some time. I hope that you recognize that the pattern was multiplied by 3, and if it is, it'll be like 150 plus 12, that'll be like 162. Hopefully that's the number you got. And then I'm going to go ahead and I'm going to make it real clear that as we increase, we're not going up by some amount. We're not adding some amount. I mean, you could say we're adding 4, but the next two, we're not adding 4 to 6 to get 18. So what we're really doing is we're multiplying times 3. And here we will multiply times 3 to get to the next, and we'll multiply times 3 to get to the next. And that is the difference between a linear function and an exponential function. If in a linear function, to get to the next y value, you keep adding a constant amount. And for an exponential growth function, you keep multiplying by a constant amount. And that is one reason why exponential functions can be better than linear functions and a lot scarier than linear functions. And they're especially scary when it comes to viruses and how they spread. And that's why we get things like epidemics and pandemics. Okay, I think I'm going to leave this video right here. Consider this an introduction to exponential functions, and we'll do some math in another video.